All right, today we're going to start with the introduction to trigonometry, oftentimes referred to as trig. We're talking about sine, cosine, tangent. Those are the trig ratios. However, there's actually 6 trig ratios: sine, cosine, tangent, and then cosecant, secant, and cotangent. And we're going to talk about how you define all of those. First thing I want to recognize is we oftentimes will use Greek letters. And it's not going to be part of like a test question, but just so you know, as we're listening to these videos and talking about things in class, there's 3 of them that we tend to use a lot of. So this is theta. The next one that looks, I draw it like a fish basically, is alpha. And then the one that's a B with a really long tail is beta. All right, again, not a test question, but just so you know, when I'm looking at this first triangle and I talk about theta, it's this angle degree right here. All right, so first thing says, and I'm going to zoom in on this first picture here, says use the indicated reference angle, which in this case is theta here, to label each side as opposite, adjacent, and hypotenuse. So there's a couple ways you could do this. It really depends on what makes sense to you. Your reference angle, if you go directly across the triangle, that's your opposite side. Okay. And yes, you can abbreviate it as OPP or just even O for opposite. Basically the right angle here will always be marked with a little box. And if you extend this like an arrow, this arrow is pointing to this side of 41, and that is always going to be your hypotenuse. All right, so the little right angle will always point to the hypotenuse, and that leaves us with one other side, which would be the adjacent side. Okay, so let's move on, do the same thing for the next little triangle here. Our reference angle is the alpha right here. If we go across from alpha, this is opposite. Okay, if we look at the right angle here, this right angle is pointing across the triangle to the side of 5 here, which is your hypotenuse. Let's see, and that leaves us with adjacent. Okay, adjacent just means next to. And so if you think about it, you could also say, well, this is the side that's next to the reference angle that's not the hypotenuse. So lots of ways to do this. Let's move on to the last one here. This reference angle is beta. All right, and if we label our triangle, again, order doesn't matter. So if you look at beta, you might actually want to go with the right angle first. Go across from that 17 is going to be your hypotenuse. There isn't a y in there, all right, hypotenuse. If you look adjacent, right next to beta here, this side of 8 would be your adjacent side, and then that would leave this being the opposite side. So however you want to do it, it's really up to you for how you want to label it, but you need to know which side's opposite, adjacent, hypotenuse in order to do your trig functions, your trig ratios. Now, the next 3 little problems here, it's the sine, cosine, and tangent of theta for the first set, alpha for the next set, and then beta for this last set. And what we need to know is, well, what's the definition of sine? What's the definition of cosine? What's the definition of tangent? And a long time ago, I did not make this up. This is something that, has been around for a long time, is the reference SOHCAHTOA. And you may have heard this in the past. I know we teach it, we've taught it maybe in Math 3. But basically what this is going to tell you is sine, that's the S, is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So that's how you remember it, or one of the ways to remember it. So if we look at our first little triangle here, it says sine of theta. Now we've already labeled our picture. So we've got opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. The one thing you want to check for is, can any of those triangles, try again, can any of those fractions be reduced? For this particular answer, triangle, no, they can't be. So let's move on to alpha, our middle triangle here. So again, we have everything labeled. Opposite over hypotenuse for sine, so 3/5. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We cannot reduce any of those, so totally fine to just move on to the last set here. Last set here is beta. So let's see, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Again, none of those can be reduced. If you can reduce the fraction, you need to. All right, so that's the first 3 trig ratios, sine, cosine, tangent, but there are 3 more, and they are referred to as the reciprocal trig functions. And the reason they're called that is because they are literally the reciprocals of your trig functions, meaning you're going to flip the fractions over. So cosecant is the reciprocal to sine of theta, which means that the fraction would be hypotenuse over opposite. Okay. Secant is the reciprocal to the cosine function, which means this would be hypotenuse over adjacent. Let me get the D before the J. And cotangent is going to be the reciprocal of tangent. So tangent of theta is opposite over adjacent. So cotangent of theta would be adjacent over opposite. All right. So SOHCAHTOA is a nice way to remember sine, cosine, and tangent. I unfortunately do not have a good way for you to memorize the reciprocal functions. What I just do is I know cosecant is the reciprocal to sine, and so I just remember that. And so I know sine, I can flip it over. All right, so let's do a couple more quick little problems at the end here, and then we'll close up this video. All right, find the following trig ratios given that, so we're given sine, cosine, and tangent, and we want to find the reciprocals. Now just be careful because they're not lined up nicely. So cotangent is the reciprocal to tangent, so flip the fraction over. Secant is the reciprocal to cosine, so flip that fraction over. And cosecant's the reciprocal of sine, so it was 3/5, so cosecant of theta would be 5/3. So that part's now done. Let's see what the next little problem here brings, number 8. All right, find the following ratios given the triangle. Now, one quick thing that I'm going to do, this is my reference angle of alpha. So if I go across, this is opposite, this is adjacent, and here's my hypotenuse. Let's see, so sine of alpha is going to be opposite over hypotenuse, so 15/17. Secant is going to be the reciprocal to cosine of alpha. Let me try and write that a little bit better there, cosine of alpha. There we go. And I know that cosine is adjacent over hypotenuse, so if I do the reciprocal of that, it would be hypotenuse over adjacent, so 17/8. And cotangent is the reciprocal to, I have no idea what I was just trying to write there, so let's try that again as tangent. All right, my brain is still on winter vacation. So cotangent here is going to be the reciprocal to tangent of alpha. Tangent is opposite over adjacent, so cotangent would be adjacent over opposite. All right. All right, let's see if I can pay attention for this last one here. Okay, so last problem in this video, and then I'll do page 2 in a separate video. We have this reference angle of theta. All right, I'm going to quickly label out my picture. So let's see, we've got the hypotenuse, we've got opposite, and we've got adjacent. Okay, and we're asked to find all 6 of the trig ratios. So let's see, I know sine is opposite over hypotenuse, so 6/10. I already recognize that this can be reduced. I'm going to go back and reduce all my fractions at the end. So I'll do that at the end. I want to get all my ratios in first. So let's see, cosine of theta would be adjacent over hypotenuse, so 8 over 10. Again, I know that can be reduced, and tangent is opposite over adjacent, so 6 over 8. Okay, now that I have the initial 3 ratios, I can use these 3 ratios to get these 3 ratios. So cotangent's the reciprocal to tangent, so that's going to be 8 over 6. Cosecant is the reciprocal to sine, so 10 over 6. And that, of course, leaves secant the reciprocal of cosine. So 10 over 8. All right, I'm going to zoom in just because I can. All right, let's do a little reducing. 6/10 would be 3/5. 4/5. Let's see, 3/4, which would make this 4/3. Let's see, 5 over 3 and then 5 over 4. That is a horrible looking 4. Let me try that one more time. All right, so this is the real base introduction to the 6 trig ratios. If you have any questions or concerns, send me a message, stop in Zoom, and we can talk, and I will post a second video that goes through the second page of this note sheet.